Knowledge Center. As you all know, I was solving a question paper of KPTCL exam. So let us continue with that. Let us start with the question number 1. So question number 1 is something like this. You can read it on the screen. You have to replace 1500 ohm resistor in radio. You have no 1500 ohm resistor but have several thousand ohm ones which you would connect in the following format. So it means very simple here. There is a radio and we need to replace a 1500 ohm resistor in it. But we don't have that 1500 ohm available, resistance available. But we have 1000 ohm resistance available. How we are going to make use of this 1000 ohm resistance? We have several number of 1000 ohm resistors. How can I connect it? How can I make the connection so that by using these 1000 ohm resistors, I should get 1500 ohms. So look into the option. Here I will give the very simple and a shortcut method of getting in options here. Okay, because in exams practically you will not be having much time to answer. You need to save the time also. So among those 4 options here, first and C, A and C option are about parallel. 2 resistors in parallel and 3 in parallel. That is the option. See, one thing you need to understand, when you have a resistance and if you want to increase the total resistance, then you have to go for series connection. When you connect 1000 ohm resistance, 2000 ohm resistance in parallel, we get it like this: 1000 R1 R2 by R1 plus R2. So one shortcut hint I will give here. Concentrate. In a parallel, when we add n number of parallel resistors together, the total resultant resistance will be less, very lesser than the actual resistance, individual resistance. If I have 1000 ohm and if I take 2000 ohm resistors connected in parallel, its value will be less than 1000. If I increase that number, if I take 3000 ohm resistance in parallel, then again the value will be less than the 2 parallel resistance. Okay, so if you simplify this, we get something 500 here. If you connect 3 resistance in parallel, you can simplify it like this: 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, so on. So when number of resistance in parallel increases, the total resistance will decrease. So keeping that point in our mind, we can say that first and the third option will be neglected. You can ignore it. 2 in parallel, that will definitely give less than 1000. 3 in parallel will also give less than 1000. But I want 1500 ohms. Okay, so those 2 options will be avoided. Now remaining B and D, look into that. In D, easily we can avoid because 3 in series. They mentioned that 3000 ohm resistors in series. In series, what happens? The resistance, total resistance R will just add it up like this. It goes on adding. So individual we have 1000 ohms. If we add 3 together, we get 3000. That is not my answer. So the only remaining option is B. That would be the answer. Now if you want to cross check, for understanding purpose I am solving it here. But in an exam, this is how you should solve it. This is how you should get the right option. Okay. So the B, they mentioned 2 in parallel, 1 in series. So when you go 2 in parallel, we get the resultant resistance as, so R1 R2 by R1 plus R2, that is the formula. So 1000 into 1000 by 1000 plus 1000. So let me write it as it is: 1000 into 1000 by, this is 2000. So all 3 zeros we can cancel, just 2 and 500. So we get 500 when we connect 2 in parallel plus series, 1 in series. So when I connect 2 in parallel, the resultant is 500 and I connect 1 in series, that is 1000. So total resultant will be 1500. So that is how the option B is the right answer for this question. Okay. So I have explained you the logic as well as I explained you how to get the option, how to come to a conclusion by looking into the options. Okay, so let's look into the next question now. So question number 2 is something like this: 2 bulbs of 500 watt and 200 watt rated at 250 volt will have resistance ratio as dash. So they are given 4 options here. First of all, 500 watts and 200 watts power they are given and voltage is given. What will be the ratio of their resistance? That is the question. Okay. So first let us find the resistance of each. So if it is, we have formula P is equal to V square by R. Actually we have P equal to V into I. right? Even that is the basic formula we use. But in this case, I want to find resistance R. So I make use of this formula. P is given, V is given. Only the thing is R you need to find. Therefore, R, if it is a 500 watts, what would be the R? R is equal to V square by P. V is 250. So 250 square is 250 into 250 by 500. If you simplify this, we get an answer. We get an answer as 125. Okay, we get it as 125 ohms. You can simplify this. 0 0 get cancelled. 5 1 the 5 5 the 25. 25 into 5 125. This is for first case if the power is 500 watt. Similarly, you do it for next case, that is if it is of 200 watts. And one thing you need to understand here, P is equal to V square by R. If power gets decreased, resistance has to increase. That is the case. So I am explaining you the logic. So resistance has to increase in the second case now because the power is reduced for 200. So 250 into 250 by 200. 0 0, both zeros cancel. So we get it, if we simplify, multiply and simplify it, we get 312.5. So this is greater than this because here the power was high, here the power is reduced, and this is the relation. Okay, so you need to cross check it like this. If you get less than 125 for getting, then that is wrong. Okay, that is how you should think. But this is not the question. The question is what is the ratio. They are not given these values in the question. Now there are 4 options. Among the 4 options, they are asking you to find the ratio of this. So ratio of this can be given as 500 by 200. Its ratio will be 125 resistance by 312.5 ohms. So this is the smaller value, this is the larger value. In option, you first find out what is the ratio they are given. They are given it as 4:25. That is possible. First we have the smaller value 4:25. So let me keep it 4:25. I will hold it. Then 25:4, that is reverse. So that option is removed. We can avoid that option. We can ignore it. Then 2:5, yes, smaller and then larger, you can consider it. Then 5:2, we can ignore that. So by just looking into the data, I am ignoring 2 options. Now we left out with the remaining 2 options here. Only 2 options. Among these 2, one is to be correct. Okay. So now look into this data, 125. Right? So by looking into this, we can say here we have 2 and we have 4. So something divided by 4 and 25 we won't get it. So we will try for this one, smaller one. 62.5 into 2 or 125 by 2, we get it as 62.5. So once we multiply this with the 2, we get 125. So we can divide it by 62.5 and 62.5 into 5, we check it. You should get this number. Yes, we get this number. If you multiply 62.5 with 5, then this will be the answer. So 2:5 will be the answer for this question. The ratio of the resistance of those two different elements will be 2:5. So this is how the problems has to be solved. See, I am explaining you the logic as well as the way of reviewing or avoiding the options, making it simple. Okay. So we are not cross-checking it for 4 options. We are just checking it for 2 options here. The remaining 2 options, we removed it easily. So that will save the time in exam. Okay. Now let's take another example. Another question. The force between 2 charges is 120 Newton. If the distance between the charges is doubled, the force will be dash. So this is a simple straightforward question. We have a relation for force, charge and the distance. Okay. If we have a charger, there is a, say this is Q1, the charge 1 and charge 2, and the force between this is 120 Newton. Okay, say this is the distance D. The relation is given something like this. Force is equal to Q1 into Q2 by square of the distance. This you need to remember. If you remember this, then you can easily answer for this question. They have given already for this relation force, how much they are given? 120 Newton. Now charges are same, only the thing is the distance has been doubled. Or let me check the question. The distance is doubled. Yes, the D is doubled. So what happens if I increase the distance? See, distance is inversely proportional to the force. If I increase the distance, force has to be reduced. And look into the options over there. we have 4 options: 60 Newton, 30 Newton, 40 Newton, 15 Newton. So all options are less than 120. So we cannot ignore any of the options over there. You have to substitute it here and calculate it. So say this is what the formula we have. Now if the distance is doubled, what happens to the, how much of change we get? See, it is d square. So what happens if I double it? It will be 2d square. So if I write it like this, I can write it like this: q1 q2 by 4d square. If I take this separately, we get 4d square. 2 square is 4. So now q1 q2 by d square is 120 Newton. That's what already we had it. So we can write this as 120 by 4. That is 30 Newton. So option B will be the answer for the given question. Okay. So you should be very calm-minded and you should be able to recall the formulas and then you can relate so that you can get the answers easily. Now let's take the one more question. See, when 4 volts EMF is applied across a 1 farad capacitor, it will store energy of dash. 4 options have been given and they are given the values. Now we need to know the relation over there. See, joules. What actually the joules? Joules is nothing but it's a unit of energy. Energy stored in a capacitor or it may be inductor. So when 4 volts EMF is applied across a 1 farad capacitor, how much of energy is stored? So what is the energy stored formula for capacitor? We know that E is equal to 1 by 2 CV square. This is the formula for energy storage in a capacitor. And they are asking you what is the energy stored in the capacitor in terms of joules. So if you do this, you will get the answer. So here we know voltage is 4 and capacitor is 1 farad. 1 into 4 square it is. So that is very important. So we get it as 16. 4 square is 16 by 2. The option will be 8 joules. So energy stored in the capacitor is of 8 joules. That is the option. Option D will be the answer for this. Only the thing, remember the basic formula of energy storage. And unit of energy will be in terms of joules only. Next, let me take the last question for this today's session. If a 6 millifarad capacitor is charged to 200 volt, the charge in coulombs will be dash. Okay. So how much of charge in coulombs we have? If the capacitor of 6 millifarads and voltage is 200. Again related capacitor, voltage and charge. So we have Q is equal to CV. Okay. If we increase the voltage, the charge will be increased. That's the point. So in this Q is equal to CV, we need to find what is the Q. They have given the values, just substitute it and get the answer. So 6 into 10 to power of minus 3 because it is 6 millifarad into voltage is of 200. Voltage is of 200. So 6 into 2, 12. So 1200 into 10 to power of minus 3. Okay. So in that option, you can go for a 1200 into 10 to power of minus 3 coulombs. Okay. So this is or you can say 1200 millicoulomb. So for this video, I will just end up this session for this much of questions because I just don't want to make it a burden or a huge video. In next video, you will get some more important questions wherein you will understand the basic of engineering and also the shortcut methods of avoiding the unwanted options and making it simple. Within a fraction of seconds, you should get the answer. Okay, so while you will also understand the logic as well as you will understand the very shortcut method to get the answer within a fraction of seconds. If it is clear for you and if you are loving it, just subscribe to my channel and don't forget to share it to our friends. Thank you.